So this one is saying right here that we have a velocity. It happens to be trig, and it's saying from 0 to 2 pi. And we know it is including 0 and 2 pi because the brackets. Very good. Then determine the following. S of 0, following information, if f sub s sub 0, if I could talk today would be great, equals 5 meters. What does that mean? Position is 5 meters when time is 0. Perfect. So in other words, initial position's 5, right? Isn't that just another way they could write that? So no big deal there. So it says determine when the particle is moving right, left, and stopped. How did we do that yesterday? Yeah, graph it. Isn't that, if you can graph, but what did we graph yesterday? Let's keep that in mind. If I'm trying to find left, right, and all that stuff, should I look at the original graph, look at the acceleration graph, look at the velocity graph? Which one's going to be most helpful if you're trying to find which way it was going? Okay, you could potentially look at position. I think looking at velocity is probably the most helpful. So let's just go ahead and graph 4 sine of t, and we've got a window there of 0 to 2 pi. So, of course, before you do that, this is trig. You can graph it in either one. But it says 0 to 2 pi on this one. So probably the best bet, radians. Or go to degrees and don't do 0 to 2 pi, but do 0 to 360, right? Its counterpart. But I don't think we want to have our x-axis going 0 to 360. It's huge. So let's just probably go to radians and work with it that way. That's why sometimes when you go and graph things and it's in degrees and you only say to go to 0 to 10, you're saying go from 0 to 10 degrees. That's why when you try and graph trig in degrees, sometimes you don't see a whole lot because you're only doing about 10 degrees of it. So keep that in mind. So I made sure that was right. Well, that was yesterday's. We don't need that anymore. All we need is 4 sine of t. Well, how do we get t? Well, we don't have to. Just put in it. All right, and then in window, well, we know it's from 0 for x to 2 pi. So keep in mind, 2 pi, and watch what it does, is really only 6.28. You know, that's 2 times pi. I mean, that's really all it is. X scale being 1, you could leave it there if you want. I personally probably would just change it so it looks better. Change it to something like pi over 2 is what I'm going to do. Because then that means every tick mark I see is pi over 2, and we know that's an important part of the unit circle, right? You could try zoom trig. I have not played around with that all that much. I'm not sure exactly what it would do. I don't know if it goes 0 to 2 pi or not. Okay. Now, this is a little bit of review, and that's why I went to this one. Y min and max. Look at the function. What is the amplitude? It is 4. So we should probably go from -4 to 4. Remember, amplitude is distance from the x-axis. It can go up and down. Y scale of 10. Does that seem like a good choice? No, not really. Probably just 1 is better. So this should give us a really good representation as to what the graph would look like. And why are we graphing it again? Because you told me to, or what? Yeah, now this is the graph of what? Is this the original graph? No, this is the velocity graph. So wherever the velocity is positive, we kind of consider that as the object going to the right. Wherever it happens to be 0, we consider that it has stopped. And wherever it is negative, we consider that it's going left. So in other words, from, well, this is obviously 0 right here. And I know I'm going to pick up a marker, and it's probably going to freak out again. Yeah. All right. So 0 to where? And that's why I made the tick mark something I knew. Because what did I make each tick mark? I made it pi over 2. So obviously this one right here is pi over 2. So from 0 to pi, is this thing going to the right, left, or stopped? It's going to the right because it's positive. Do you include 0 and pi in that analysis? No. So if you're going to go interval notation, you probably better not use brackets. You better use parentheses. So you would say basically it's going to the right, 0, pi, right? And then does it go left at all? From pi. 2 pi included or no? Nope, because 2 pi, it's not going left at 2 pi, it's actually stopped. And this is something that didn't happen in our notes yesterday, but it actually stops in more than one place. And it actually stops where when we start. So it stopped at 0, pi, and 2 pi. And basically, the thing I really wanted to pound home today is that if you want to find left, right, or stopped, the easiest graph to look at, believe it or not, is the velocity graph. I believe. If you want to, obviously this is something you could go find the position graph if you'd like, and you could look at that. But I just think this one's a little bit easier to look at the velocity graph to answer that question. So that actually pretty similar to yesterday's, right? Nothing really overly new on that one, except watching out for the trig when you graph it. Now the next question on the notes. So we answered that one. Determine the particle's final position. Well, it says here that it started at 5 meters. And how is position related to this velocity that we have? We know v of t is 4 sine of t. How are we going to find position? We have to integrate. And we have to find what's called displacement. That's what the integration finds. How much did it move? We know it started at 5. Where did it end up? So we are going to take the antiderivative of 4 sine of t. That's what it is, right? Zero, 2 pi. Is this the one I should put absolute values on or not? Why not on this one? Because if it goes right or left, does that make a difference of where it's going to end up? Yeah, if I go right and then I go back left the exact same amount, I didn't really go anywhere. So left and right is important here. And this is possibly where the glitch will happen on the 83. I'm not sure where all the glitches happen, but I know it did happen on the 83 I was using last year. Because now this is where we did that, right? We would solve that right on here. So you would go to calculate. I'm hoping this doesn't give the glitch. I really hope it works. Obviously, we are going to integrate, so that's number 7. And the nice trick that you taught me is you just type in 0 for lower limit. And for upper limit, there's the glitch. Does it even happen? You have the different notation, correct? Or no? Okay, on the graph it didn't work. Here's why. I believe the glitch is that your graph ends at 2 pi and it doesn't really know what to do. So it's a very simple fix. How could I fix my graph ending at 2 pi? Go to your window and make it 2 pi plus 0.01. Now my graph doesn't end at 2 pi. And now, whoops, it should work. Zero, enter. 2 pi. Basically what it has to be is some glitch in the programming. That if it ends there, it's not going to work. That's all it has to be, is some glitch in that. Do we agree with 0? The area underneath the curve is 0? That's because all that stuff on the right there is negative and all the stuff on the left is positive. So basically then, what is the final position? Yeah, basically this equals 0, right? So as far as it moved to the right and left the same amount. So we started at 5, we moved to the right, well, it actually ends up being 8, and then we moved left 8, and so we were right back at 5 that we started at. 5 meters from where? Well, we don't know, but we know we're at 5 meters. Perhaps 5 meters from the origin.
Here to do like the antiderivative way, like whole math, right? The math thing first, then switch.
The question whereas if you go to the one where I showed you in the program, if you did that, no, it does not, because it's not relying on your graph. If you go to fint and type all that stuff in, it should not give you a problem because, like I said, it does not rely on your graph. Okay? Where this one obviously does, the way we did it here. So that's where you have to make your choice. Which way is going to be quicker, but you know multiple ways. So if one doesn't work, use the other one. So how about total distance traveled? This one could actually be a lot easier if you let it be. Didn't we just find out that this is completely symmetric? So if I were you, now you don't have to do it this way. Could we do the absolute value method that we did yesterday? Yeah, most definitely. It's going to work. But if you think about it, what we could do is figure out what just one of those is, because isn't the other one going to be the same amount? We just found out it's symmetric because this is 0. So what you could do if you wanted to in this case is do that and just go 0 to pi, because we know that's halfway. We find out that that much is 8. This one on the left is 8, so what's this one on the right is also 8. So what is the total distance traveled? 16. Yeah, I went right 8, left 8. I kind of told you that earlier. We went 16. So 16 meters is how far we went. Again, the absolute value would work. But again, if you're going to go to the calculator, what if I had it ending at 2 pi? Well, it's not going to work again. So you have to get it out there just at. And notice, did I go out much further? What did I go out? Another 100th? And it was allowed it to do it? Okay. So there must be something in their programming that they have to do something minus something to find out what works. And unfortunately, they're probably getting 0 when they do that, and it's not making it work for us. So it's a programming error, but there's ways around it. So any questions on the first one? I have not called Texas Instrument, and I'm pretty sure they would never take my phone call. But, we could try something. I'm sure that, yes, they would stop and read that after my email.